everyone, my name is Jitesh Gotmare. I am studying in College of Engineering and Technology, Mogaon, Nagpur, from Civil Department, year 5th sem. So we are discussing about the DSS design of steel structure, in which my topic for today is the welded connection. In that, we are going to solve the equation given to us, that is the diameter of a truss is made of ISA 17 to 8 mm, and it is subjected to a force tension load of 80 kilonewton. The length of an angle is not enough to go from end to end, and hence a slice has to be provided, a design grade root weld joint. So this is the diagram we are going to draw here. This is the joint, and here it is going to be welded. Diameter is 70, 6, 7. The measurements are given in the equation ISA 17 to 8. So there is 70, this is 70, and the thickness is 8. The thickness of this welding is going to be 8. That is placed here. So let's start the equation. Let's solve this equation. So there are some values that is not given in our equation, so we have to assume that value. As for the assume single weld joint and assume the grade of the steel. The grade of steel is not given in the equation, so we are going to assume the standard from the ISA code. The standard value for a grade of the steel, that is Fe410, and for to find Aw we have to add the both diameters of the welding, that is 70 plus 70, our answer is going to be 140, and ISA 17 to 8 mm, that is given in our equation. Here the diameter of a truss is made of ISA 17 to 8 mm, that is given in our equation, so we are going to write it as it is. The PT is equal to 80. PT is equal to 80 kilonewton. This here is given. The PT is nothing but the force tension load, that is given in equation, that is 80 kilonewton. So the first step is the thread of the weld. Formula for the thread of the weld is 5/8 into T minimum. So T minimum is nothing but the thickness that is given to us. Thickness is going to be our T minimum. So 5/8 into 8, that is 5. So because 8 and 8 is going to be crossed and 5 is remaining, so 5 mm is going to be our thread of the weld. Second step is strength of the weld. To find the strength of the weld, the given formula is Aw into Tw into Fy divided by gamma mw. Lw's value we have find here, that is 140, nothing but the diameter of the both side weld, 70 plus 70, 140. That is Lw is 140, Tw is 5, thread of the weld. Tw is nothing but the thread of the weld. We have just solved it, and our value is 5, and into Fy. Fy is also nothing but the grade of the steel that we have assumed here, 410 divided by m naught w. M naught w's value is given in our IS code, standard IS code, that is 1.25. So if we put the whole value in this equation and solve it, our answer is going to be 22.9600. It is going to be in Newton, so we have to make it in kilonewton. So our answer is 229.6 kilonewton, which is greater than the 80 kilonewton. So it is safe to assume that our design is perfect.